Welcome everybody to another one of James's videos. Today we are dealing with another hard example or more difficult example, solving for 2D triangles using your sine rule, area rule, and cos rule. Okay, so looking at this question 11, in the diagram, HTP is a straight line. HTP is a straight line. Okay, great. ST is perpendicular to HP. Okay, cool. So 90 degree, 90 degree. Then we have SHT equals Z. Fantastic. Then we have STK equals Y, KPT equals X, and then HT equals KP, which equals H. Okay, so HT equals KP, they're both H. So all the information being said in my question has been represented on my drawing, so I am in the clear there. Awesome. Now we're going to do question by question. So 11.1, write down KTP in terms of Y. KTP is this angle over here. This angle over here. So we know that this whole angle from the whole perpendicular thing, that's 90 degrees, which automatically makes this 90 minus Y. Okay, does everyone agree with that? Let's zoom in just to make it a little bit more neater. So this is 90 minus Y. Fantastic. Okay, why is that? Obviously, it is because of complementary angles. If the whole angle adds up to 90, all the angles are complementary. So we can say there, KTP equals 90 degrees. Sorry, 90 minus Y. Reason, complementary angles. Okay. Fantastic. 11.2. Let's have a look. Prove that KT equals that. Okay, cool. So KT is over here. So let's just make it green. KT is over here. So which triangle would you use in order to prove KT is equal to that? Also looking at what is in your answer, H sine of X and cos of Y. So I would be using the triangle KTP here because it has all those letters in. And what rule would I be using? Well, the rule that I would be using would be sine rule. And how do I know that? Well, I have an angle, I have a side opposite that angle, so I have an ordered pair. I've got the angle, but I'm looking for this side. So I have three knowns and one unknown, which allows me to use the sine rule. So we can say KT over sine of X, because that's the angle opposite KT, is equal to H over sine of 90 minus Y. Immediately, we should be seeing something there when we see that 90 minus Y, everybody. Okay, so therefore, let's make KT the subject of the formula. So we're going to bring the sine of X up, and we're going to have H sine of X all over. What is sine of 90 minus Y, everybody? That is cos Y, isn't it? Co-ratio. Okay, I'm going to highlight that. So from that to that, co-ratio. Okay, we can't forget that. Okay, awesome. Okay, and there we've got the answer that they wanted, huh? Proven. Fantastic. Let's look at number 11.3. So 11.3, we are dealing with ST. So let's highlight ST quickly. And we are looking for H tan of Z. So H or ST is a part of this triangle, which we can now use SOHCAHTOA for, right? Because it's a right angle triangle. Remember, KTP triangle is a non-right angle triangle, therefore I used my rules. But SHT is a right angle triangle, which means SOHCAHTOA is in place. So let's see what we have. So we've got the angle, we're looking for this side, which is opposite the angle, and we have the adjacent. So what trig function deals with opposite and adjacent? Tan. So tan of Z equals my opposite side ST over my adjacent side, which is the H, which is HT. So therefore, H tan of Z equals ST. And isn't that what we wanted to solve for? Yes, it is. Fantastic. Okay, great. Now, 11.4, let's have a look. So 11.4 is saying, prove that the area of KTS, now we've got a different triangle here, guys. Oops, let's put the highlighter on. KTS. I want that area. Now, what scenario does the area rule follow? How do I know I'm using the area rule? It's a non-right angle triangle. So what do I know the scenario that the area rule follows? It is the side angle side, or the V shape. So do we have a V shape here? Yes, we do. Let's put in our known information we worked out from 11.1 to 11.3. So do we not know that ST is equal to H tan of Z? And do we not know that kt is equal to h sine of x all over cos of y? So do we not have a V-shaped scenario here? We've got that, and we have the angle y in the middle. So that allows us to use area rule. So let's see. Area is equal to a half times, and I'm going to write it out in letters first, just so that you can see what part of the triangle I'm using. So it's the ST times the KT sine of t. So therefore, the area is going to equal a half h tan of z times h sine of x over cos of y, running out of space here, and sine of y. Now, everybody, I'm going to change everything into fractions just so that it's easier to work with. So we've got a half, right? We've got times by h tan of z, and that would be all over 1, times by h sine x cos y, times sine y over 1. So now, according to me, how fractions work when we're timesing, we would times everything at the top by everything at the bottom as well, right? So everything at the top, you would times together everything at the bottom. So the area equals 1 times h tan z times h sine x times sine y. So that's going to give me, let's leave the half in the front, and it's going to be h squared tan of z sine of x sine of y all over cos y. But doesn't this become a tan? Sine of the same angle over cos of the same angle gives me a tan. So I can create a tan there. And that's an identity, everybody. So tan of z, sine of x, tan of y. And that is what they wanted you to prove. Okay, so again, very important to know our, I'm just going to do that, and I'm going to do that, identities, hey? Fantastic. Okay, cool. So that's finished, guys. So now 11.5, again, like I said in the previous question, 11.5 is a substitution question, just calculator work. So they're wanting you to know what is the area of KTS nearest square meter if H equals 28 and all the above. So let's go. Half 28 squared tan, what was Z? Z is 61.6 according to the question. Sine of 115,7 and tan of 43,5 degrees. And you put that into your calculator straight away. Let's see what we get. So we've got a half times 28 squared times tan of 61.6 sine of 115.7 and tan of 43.5. Okay, so I've got 619,93, and in this case, what is it going to be? Units or meters squared. And they want it to the nearest square meter, so I'm going to say it's 620 square meters. Okay, fantastic, everybody. So, just to recap, we did quite a bit there, but at the end of the day, we managed to get it remembering our identities, remembering how fractions work, and getting to the final answer. Cool, great. I hope you enjoyed that video. Definitely more to come. So please, if you liked it, click the subscribe button below, and you'll be notified if any new ones pop up. Also, all these notes are available in the James book, which is for sale. So if you are keen to have one, please get in contact with us and we can make it happen. Awesome. Hope you have a good one, guys. Enjoy. See you at the next video.